Alright, look closely at those. Jesus, I trip and kill myself. At those lights there. Oh, that one's going to come on. But that one up there, see how it's dim? In a minute you're going to see it come on. There it is. Alright, that's the way it should be. And it's not the dull bright lights. I'm not going to shine this in there so we all go blind. It's not the dull bright lights. I've already checked that. That doesn't have that setting. The lights just never go off. They're always on. If you come in the daytime and even cover up the lights, you can see it. They're on like that dim setting. All right, don't mind all the noise. Here's our suspect light from the outside. I took it down and brought it inside. Now that it's snowing outside, good place for it. The one thing I didn't try, but I believe I've done it before when I've had this issue with other lights, was to cycle the power to reset it. If you look, this is definitely an old school kind of sensor here. All it has is test and auto. I don't even know. Maybe that's how you set the sensitivity of it. But anyhow, what I'm going to do is, you see I had my little meter set up here, so I want to just see what kind of current we were drawing, or what kind of power consumption it had. So don't try this at home, boys and girls, but I just shoved the wires right into that, and we'll see how this works. So let's see if I can do this without electrocuting myself. Oh, there. All right, the lights came on. Obviously, you're seeing that. So let's look at 20.2 watts. I don't know if you can see that. I don't want to move with it too much, or the wires will pull out. But 20.2 watts is what it's taking right now. I wonder if I can see what the current is. I can't see what that top thing is. But see when it, maybe they'll reset and go off, and then we'll get a look at what's happening. So yeah, here, just killing a little bit of time. 20 watts. Now these are two LEDs that I put in here, and I don't know what the ratings of them were, but I took out I think they had the 100 watt bulb in there. I don't know if it's thinking it's that dark that it should be on, or what. Maybe spin this so that it's going to get some of the light. You're just watching for a spark. You're just hoping it sparks, aren't you? Let's see. Well, I have it. So we'll give it a couple seconds to use. Well, maybe a minute or so, see if it's going to go off. I don't know. Know any good stories? All right, so let's see. Let's look at the function. That's kilowatts. That's volts, 117 volts. I don't know if you can see this. It doesn't really light up, and I don't want to turn it too much. Amps is 0.264, so a quarter of an amp. Somewhere in that area. Go back to our watts, 20.2 watts. What does this little guy say down here? Auto and test. So I would think in test, they should turn off almost immediately when everything stops moving. There we go. So now I'm going to try and back away from here, and you can come over and get a look at these lights when I turn everything off. Try and turn that off too. They should go off pretty quick. Okay, they're off. Let me kill the lights now and see what happens. Alright, you can see that the LEDs are staying on a little bit. Move the camera over there. See how they're kind of glowing. I'll pull this wire out and you'll see what I mean. It's not there. So they're always staying on a little bit. Alright, I pulled both wires out. We're safe. Let me go turn some lights back on. So, that means that probably what's inside this is staying on. Okay, let's see. I wonder if this can be serviced. Who knows? Who really knows? We'll get a little Phillips screwdriver and we'll see what we have to do to take that apart. Get all this crap out of my way here. You know what I forgot to see was how much current it was drawing when the lights were staying on. Darn it. That was the main reason I hooked this darn thing up. Alright, hopefully I don't electrocute myself again. Not like I did before, but... Alright. So it's still in test mode, so it should be relatively quick. Let's see. Function 19.9, so it's about the 20 watts. There they just shut off. Dropped down to 0.6 watts. So .044 amps. So it'd be 1, 2, 3. 1, 2, 3. So it'd be 44 milliamps. So not that it's that much, but I wonder if you have incandescent bulbs in there, what kind of power it consumes. Because remember, they'll act like more of a short. So let's try them. I'm going to unplug this and go get two incandescent bulbs and try it. Alright. See, I don't even know if these bulbs both work. Let's find out, shall we? Yeah, they both work. They're drawing, oh come on. They're drawing 207.6 watts. These are those halogen bulbs that they just went out. So let's see what they're drawing when they go out. About the same thing actually. 0.6 watts. Let's go to amps. Conjunction, junction. Oh, yeah, 0.044. Now let's see how many amps they draw. So when they're turned on, did I shake something? When they're turned on, 1.77 amps, so almost 2 amps to run these. So you can see the savings, the difference in savings when you use these LEDs over those halogen bulbs. I can't see how many watts they are total. Interesting. I don't know if we can see that. That's plastic. The rest of it's glass. And it's heavy. It's a heavy bulb. It's heavier than these. Alright, enough about reviewing light bulbs. Pull that out. Unplug that like so. Grab my Phillips key screwdriver. Pull this out. I'm not really sure what we're looking at now. I guess you can still kind of see what I'm doing here, yeah. All right. Let's see. Let me go. I have to open this drawer, so I got to move this back a little bit. See if I got one of these doohickeys that'll fit. Not little and tiny, but maybe it'll fit in there. Oh, look at that. An older one, I wouldn't expect that the newer ones would come apart the same way. All right. All right, we're getting there. All right. Oh, I can see what's in there, can you? Let's see. What do we have to do to get the circuit board out of there? I would think it would just pull out. Hope there's not some big nasty capacitor in there just waiting to zap me. So let's see. Oh poop, I cracked the front. Well, it's kind of dry rotted actually. Here we can see it's the light sensor and its motion sensor. That's pretty tight, isn't it? Alright, so that comes off. Where are we at? Can you see it? Alright. The juice wires come in. I just wonder if it could be something as simple as the contacts on the relay aren't completely opening. I would think if that was the case, that when I put the incandescent bulbs in, it would have drew more current. It's almost like it's limiting what goes to the bulbs when it's turned off. Not just my thought. I never even looked if these things are meant to be used with LEDs, because they have such a wide voltage range, and they will come on dim at a lower voltage. I was just curious what it used inside. I thought it used electronic switching, but it looks more like it's using a relay for its switching. So that may be the difference in the newer and the older stuff. Alright, so there's one more thing I want to check with this. I just want to see what kind of voltage is going to be present at the bulb. So you can see that's still kind of glowing a little bit, so we know that it's 0.6 of an amp. Let's see what kind of voltage is present at that. Inside there. Oh. So I can do this without electrocuting myself. I'm going to assume it's going to be AC. Alright, put this on here, like so. Reach in with this guy. Come on, auto range for me, please. Let's see. 76 volts is present. So that's considerable, actually. I didn't think it'd be that much. So let's see, we're looking at, last I want to see is, I can't spin this around because it'll pull the wires up, but I'm looking at 0.6 of an amp. Let's see when I unscrew this other bulb. Okay, the light has gone out. It is still 0.6 of an amp. I'm sorry, 0.6 of a watt. So let's look at amps that'll break it down a little bit further. Okay, 0.44 amps. That's what it was before with this in or not. I think I can. Okay, it's in. Didn't really change anything. I'm going to take this out. I still have about 0.044 amps. So that's telling me that alone is what's powering up that circuit. And I don't know if that's typical. I do have another one of these around. So let's see, we can do this. Let's get this out of our way here. This is just another sensor. We'll put it in test mode. And we'll see what kind of current this draws. But it's in its sleep mode. And this is an older one, but I thought I'd swap that out, but I can't put it on this type of a housing, because as you can see, this uses a nut, whereas that one kind of suppressed in looking thing. But let's get this out of our way, and I don't know how that functions either, so that was just one that I had laying around. But while we're here testing stuff, we'll check that out. So I'm going to unplug stuff and get this out of our way. Alright, you're out of here for now. And let's look at this guy here. So let me plug this in like this. The white will go on the big side, the black will go on the little side. And realizing I don't have any light bulbs, so we really don't know what's happening with this one. But we'll plug it in and see what happens. Alright, well this one here, you can see that it's, I don't know if you can see the little red light flashing. It's not drawing any current right now. I mean, I'm sure it is, but this only goes so low. Alright. Let's put one of these bulbs in here. Like so. And I'll jump her from the red to the black. Let me pull this out of here so that I can kind of do this without causing any big sparks. Okay, so that's off. We'll jump her from the black here to the red. And then I'm going to need another jumper. And go from the white here and into the white here if I can hopefully get to it. Now we'll plug it back in and hope for not sparks. Okay. Let's make sure that that's, oh, I thought that was on. Let's put this in test mode, which I think it is. Yeah. So theoretically that should go off in a second or two. Oh, it's, right now it's pulling 7.5 watts. Now 8.9. This is the dull bright. So let me make sure that's all turned off. The dull bright means that the lights come on a little bit, and then when there's actually motion detected, they come on to full brightness. This one was messing up. Okay, it's gone off completely. I don't know if saying two tenths of a watt when it was off. Let me go and turn the lights off again and see if that one's coming on dim as well. Ooh, scary. See anything being on. That doesn't look like that one's coming on at all. Move my arm and make it trigger. There we go. Alright, let me check what the voltage is on this one when it's not doing anything. If I can do this without blowing myself up. So what am I showing? 69 volts, that doesn't sound right. Am I going to get it to... Still showing that it's pulling 0.2 watts. Oh, that's not good. $70-some volts. So this one's only putting out 70 volts. Let's try a different light bulb in there and see what happens. Remind me that that's live. Interesting. Now I think with this one actually the problem is that it worked, but the lights weren't super bright, but the thing was it was using those halogen bulbs. Ah! You'll notice I didn't want to grab anything. Okay, so let's put this guy back in here. And let's put this and touch this and see what we get. Yeah, it sure isn't that bright, is it? Yeah, I'm on the wrong probe. I'm testing both hot sides. Let's go here. And here. Alright, so that's 62 watts at 105 volts. But that certainly doesn't look all that bright. I mean, I don't know, probably can't really get the gist of it through the camera, but it has a yellowish look to it. Sure, is a lot of heat from that. But anyhow, it ends up, we're looking at 63 watts. What was it before? 8. So the considerable savings again with those other bulbs. Let's see when it's not lit up, what the draw is. Again, 0.2. It drops down to 0.2 watts for the draw when there's nothing happening right now. So there's no change in that. It's just the light on time. And I don't know if that's typical. We'll have to try a newer one of these. If it's typical that that the voltage would be different depending on the load. Like this is more of just a resistive load. This is almost like a direct short. Well, not a direct short. This is more like a resistor wire across the terminals. And then when you take it out, there's very little load. So this isn't turning on that much. Almost like it turns on as needed. So you can see when I'm using the LED, they're a higher resistance. They're more of a, they have components rather than just a wire that makes the resistance. So that could be a capacitive or inductive load, more like a reactive load as opposed to a resistive load. So that would be higher. We'll test it with the ohm meter, and I'm sure it'll much higher resistance on one of those bulbs than these. So that could be another money saving, if that's the way these are supposed to work, or if this is just malfunctioning. Like I said, it seems odd that that's not that bright. So it's like it's not turning on completely. Alright, I'm going to pull these out of here so we can do the ohm test, and I don't want to make any sparks. So let me get these all disconnected. That's all, everything's safe now. Problem is when you get all these wires, it starts to get, you forget what's what, or what not to touch. So let's check. What do we think the ohmage, the resistance is going to be on this? Oh. Let's see. Alright, there goes the resistance on this. Can you see? Go to that and that. 17.5 ohms. 17.5 ohms. Now let's look at the resistance on this. Since it's probably more like, yeah, it's not really infinity. It's just, it doesn't show a DC. It's more of a reactance. When AC is going into it, then it'll show. How do to the AC voltage or the AC line, this will look like a load, even though to DC it's looking like an open circuit. But that's why this doesn't use a lot of energy and generate a lot of heat. It's more efficient, let me just put it that way. Like I was saying, that's not a resistive load. Okay, and aren't you lucky? I just happen to have another one of these. It was actually, I think it's a brand new one. It doesn't look like it was ever put on anything. So let's just take a couple looks here with the light on, what kind of voltages I'm getting. Alright, this one's showing 120 volts with the LED light, so showing exactly 10 watts being used. Let's go to current. Current's a quarter of an amp, 0.126. Let's see, what's that? An eighth of an amp, rather. Okay, the light just went off. Current dropped down to 0.027. Ah. 0.027. So this one seems to have a little bit of a higher resting current. 0.027. It doesn't look like the LED's on. I'm going to get up and turn the lights off just to confirm that. Nope, they are not on. See if I can sneak in there now and get a voltage reading when there's no power on. I'll turn this away. We'll see what the voltage reading is when there's Let's see, lap hoop. Let me look on this one. About 120 when it's turned on. Oh, it's dropping way down. About 2 volts it looks like. Certainly not enough to turn the LEDs on, so I found out that other unit's faulty as well. This guy here. This guy here. Let's throw that one out. Okay, so I think we got our solution now. And there's really not a... Well, the newer ones, there might be something serviceable in them, but generally there's not. So I guess I'll have to replace that. But that's all I have, so thanks for watching. Maybe if I get really motivated, I'll make another video if I tear one of these apart. And see what makes it tick. But thanks for watching, and hope it did you some good.